Hello, my name is Jason Keagy. I'm at Penn State University, and I want to tell you about a project that got started quite a long time ago at Michigan State University with these wonderful people here: Whitley Leto, Ross Mentor, Sarah Machniak, Onyx Baird, and Jenny Bauman. And I'll give away the punchline, but what we found was repeated parallel differentiation of social learning differences in benthic and limnetic stickleback. Here's a benthic stickleback hiding over here. And I'm happy to say that this work is, by the time you see this video, should be out in biology letters. I think many of us find social learning fascinating. In fact, we're practicing social learning when we watch videos such as these. Getting information from others can be a cost-effective and risk-reducing method. So meerkats learn to handle dangerous prey, zebra finches learn about nest building, and we learn important life skills like how to touch our nose from watching others. There have been a number of hypotheses proposed for the expected phylogenetic distribution of reliance on social information. The first and most popular hypothesis, the social intelligence hypothesis, is that social species evolve to take advantage of the greater amount of social information available to them. And one prediction of this hypothesis is an increase in the size of brain regions involved in social learning, although that's problematic, with group size. That's what's shown here from Dunbar's 1998 paper with primates. He certainly pushed this hypothesis quite a bit in the 90s, although the hypothesis itself dates back to the 60s with Alison Jolly and 70s with Humphrey. A second non-mutually exclusive hypothesis is the predation risk hypothesis, and this suggests that species that are more at risk for predation should rely more on social information because the costs of using individual information are increased. And this hypothesis was promoted by Kevin Leyland to explain differences between two stickleback fish species. Here, this is a 3-spine stickleback, and it has really large spines, lots of armor plating. And then there's a 9-spine stickleback here that has many more spines, but they're less effective at preventing predation. So the idea here was that the 9-spine would benefit more from using social information than the 3-spine, and indeed the 9-spine was able to do something called use public information. It was able to tell the difference between food patches and quality, whereas the 3-spine stickleback was not, and this has been replicated across comparisons across the entire world. However, that type of social information, and also the paradigm I'm going to talk about that's a little bit simpler, relies on delayed use of information from other individuals. And in that case, we might actually expect a trade-off with group cohesion, especially if being with the group is super important for your fitness. And so therefore, we propose a third hypothesis, the group cohesion trade-off hypothesis, that social species rely less on certain types of social information when maintaining group cohesion is important. And our goal was to test these hypotheses in closely related species of fish that differed in social behavior, rather than using large taxonomic groups that might have other sources of variation. So enter the benthic-limnetic species pairs from British Columbia, Canada, over here. They evolved after the last ice age, so relatively recently in terms of geologic time. They're reproductively isolated, and there's both ecological and sexual selection against hybrids. The benthic form is a generalist that primarily skulks. In the vegetated areas, it's much less social, although it does, it will do some social behavior. The limnetic form is more slender, and it forms these shoals that are really important for its survival in the open water where it's eating plankton during much of the year. Importantly, there's been replication of a divergence between the two. So I'm showing you 2 lakes here, Paxton and Priest, and this gives us a really nice natural experiment. The originally described replicate was from Enos Lake, and tragically, those benthic and limnetic species have collapsed into a hybrid swarm after crayfish were introduced. And we were also curious to know how fish that look benthic and look limnetic in that lake might behave. So here's the paradigm that we are using. It's testing delayed local enhancement. And this is when an area becomes more attractive because of recent presence and or behavior of other individuals. So we have an observer here in a plant refuge. And then there's two demonstrator shoals, one here and one here. And then there's these feeders that are basically these tall square columns. One side is getting fed bloodworms, 3 bloodworms. That's the favorite stickleback snack. And the other side is only getting fed water the bloodworms were in. And there's a clear front to these feeders that the demonstrators can see into, but the observer cannot. What the observer can see is these demonstrators trying to get at the bloodworms through that clear front. So it extends the behavioral cue and makes it very salient. Whereas these individuals here that are not getting fed through the feeders were going to tend to be more random in their movements in the tank. And so we do a series of feedings, and then we remove the demonstrator fish and all these dividers, and we ask this fish that has now not eaten for at least 24 hours, so it's hungry, where it would like to go. And we can ask whether it went to that enhanced side first. And we can also calculate traditional preference scores. Let's step through these predictions that correspond to the hypotheses I told you about. So the social intelligence hypothesis predicts that social species should be more reliant on social information. So there we would suggest the limnetic fish should be more likely to use social information than the benthic fish. The predation risk hypothesis suggests that species, or predicts that species with higher predation risk should be more reliant on social information. But who is the species with the higher predation risk? Maybe fish are more high risk because they have smaller spines and less armoring. But in fact, the ancestor of both of these forms had even more armor and bigger spines than the limnetic fish. And so the thought is that there's actually been reduction, especially in the benthic form, due to lower predation risk than the marine ancestor. And so in that case, the limnetic fish would be thought to use social information more. And what we can do is we can actually ask the fish, by looking at their behavior, how they feel their current predation risk, how intense that predation risk is, basically look at how risk averse they are. Okay, and the third hypothesis actually makes a different prediction. And that is that social species should be less likely to use this delayed social information. So in that case, the limnetic should be using it less than the benthic. So let's look at the results. I have lake on the x-axis. I'm going to hide enos for now. We're just going to focus on the intact species pairs. And then I have on the y-axis the first side chosen. So this is the enhanced side. This is just staying in the middle the whole time. And this is the control side. And it actually doesn't matter whether we analyze with or without these fish that didn't choose a side. Same results that I'm going to show you here. These little dots are the individual fish, and then we have means and standard errors. And what we see here is that there's a consistent difference across lakes. So we have parallel differentiation with benthic fish using that delayed local enhancement information and limnetic fish not. When we look at preference scores now on the y-axis, we see the exact same thing. And now let's see what happened at Enos Lake. There's actually been this reversal here, where limnetic fish are actually tending to use that information more than benthic fish. Benthic fish might actually even be showing some avoidance of that side that was enhanced. Now, what about those behaviors that relate to risk aversion? So if we look at latency to move now on the y-axis, the limnetic fish are actually taking longer to move once they're able to, once they're released, suggesting they're more risk averse. In Enos Lake, it's hard to see on this figure because I'm plotting the raw data rather than the transformed data that was analyzed, but there's a reversal again in that behavior. And then when we find no differences in hiding under the plant, if anything, there's again a trend for limnetic fish to be hiding more and be more risk averse. So limnetic behavior suggests, along with their morphology and that they are more risk averse. So let's go ahead and recap. What did we find? If we just focus on the 2 lakes that had intact species pairs, limnetic fish use social information less than benthic fish, and so we can reject the social intelligence hypothesis. We also found, again, evidence that the limnetic fish, they have morphology, they also have behavior in the lakes. The fact that they are forming these shoals is actually anti-predator behavior, and their behavior in the assay itself suggests they're at more risk for predation. And so we can reject this predation risk hypothesis. Whereas we find support for the social group cohesion trade-off hypothesis that social species are less likely to use delayed social information. And interestingly, something else is going on in Enos, and we see something similar in when we look at brain region size differences in these 3 lakes. So hybridization is certainly causing some different patterns there. Okay, with that, I would like to thank various people that have given us money and various people that have helped us. And thank you for watching this video.